Alright guys, today we're on Unit 3, Lesson 1, and we're going to be graphing systems of linear equations. We're also going to be doing inequalities in this video, or I may do a separate video. We're going to be able to, when we're done, determine whether a system has 0, 1, or infinitely many solutions. And we're going to be able to solve systems of equations by graphing them. Alright, so as our warm-up, let's go ahead and talk about, what a solution set looks like. So if we plug in ordered pairs to solve for y equals 2x minus 5, if we test 1 and negative 3, well, 2 times 1 minus 5 is negative 3, so that checks. 2 times 4 minus 5 is not negative 3, that's 3. 2 times 7, 14 minus 5, is not 6. And 2 times negative 13, negative 26, minus 5, 2 times 4, negative 4, negative 8, minus 5 is negative 13. So that works. And actually, I gotta go back and do this one. 2 times 6 is 12, minus 7 is 5. So that one works as well. So you can find solution sets to ordered pairs by understanding, how you plug in for x and y. You can also solve systems by using algebra. So we know, like, we subtract 2, we get x is equal to 8. We distribute, we get this situation. We know that this is going to end up being 4 equals 4, which is infinitely many. And then when we do this, we know we're going to end up with negative 3 is equal to 5. And so we understand from before that that's a no solution set. And so what we're going to look at today is how do we do all of this but in a calculator. And so we're going to take a look and we're going to start with, just a simple linear equation. Y equals 2/3 x plus 1. So I go to 1, I go up 2 over 3, up 2 over 3. And I draw the line. Then I go to this one, and I go minus 2, and then down 1 over 3, up 1. And so we've graphed these. So where do they intersect? Well, they intersect at this point right here, which is negative 3, negative 1. This is also our solution. This is also our solution because this is the point at which the graphs are equal. And so in order to check that, you have to plug in negative 3 and negative 1 back into the equation. So we would do, 2/3 times negative 3, and we get negative 2, plus 1 is negative 1, so that checks out. Then we do negative 1/3 times negative 3, and we get 1. 1 minus 2 is negative 1, and so that checks out. So both equations check out. But my question is, if you could figure out a way to do this without doing all this work, wouldn't you do it? And that's what we're going to get into today. So a system of linear equations is one or more linear equations that are put together. And when you're asked to find a solution to a system, you're being asked, what is the exact point that is a solution to both linear equations? So remember, we talked about that, and we did the warm-up on the first page. And remember, there can be none, one, or infinitely many solutions to do this. So one way to do this is to graph the linear equations and find where they intersect. So we graph the linear equations and we find out where they intersect. As a review of what we did here, I want you guys to go ahead and graph these two equations by hand. Okay? So go ahead and do that, and we're going to talk about what happens when you do these two by hand. So do these two, and then pause the video, and we're going to look at the graph. Okay, so hopefully you guys were able to graph these, and you were able to find this has a solution of 1, 4. In the second slide, when you graph them, they don't intersect. Parallel lines have no solution. There's one more here, and I'm just going to do it real fast. And I'll just tell you that after you fill this one out, you're going to end up with this. So what ends up happening is we graph it the first time, but then when we go to graph the second line, we realize that this is the same line. So if your equations come up and they are the same line, then it's infinitely many. So let's come up with some ideas. If your graph crosses in exactly one spot, they have one solution. The slopes will be different, and so will the y-intercepts. If your graph looks like this, there are no solutions, and your slope will be the same, but your b will be different. If you graph and you end up with one line, it's infinitely many, and your slope and your y-intercept will be the same. So hopefully that all made sense. So here's an opportunity for you to look at these and determine if these graphs have 0, 1, or infinite solutions. This is your homework check. We'll go over these in class. Also, what we're going to do in class is we're going to use the calculator. Now, I don't let you take a TIA3 home, so you're just going to have to follow the steps, and we'll do these in class. Make sure each equation is lined up in y equals. And so then you click y equals on the calculator. You enter the first equation and click enter. This will drop the cursor to y2, or you could click the down arrow. Down. You enter the second equation in and you click enter. Then you're going to click second trace. And once you do that, what we're calculating is the intersect. So we're going to click 5, and we're going to find the intersect, and then you're going to hit enter 3 times. And your answer will end up being at the bottom of the screen. So let's go ahead and do one of these together, and then this is where I'm going to stop this video, because I want to just focus on equalities, then I'm going to do a separate video for inequalities. Okay, so we're just going to do one of these together. Like, I'm going to show you one on the calculator, and then we'll do the other one in class. So I have y equals. I'm going to clear out my current y equals. Maybe I am. Clear. I'm going to put negative x plus 1, and I'm going to put 3x minus 4. Whoop, no, I'm not. I'm not going to do it like that. I'm going to hit enter or down arrow, and then do 3x minus 4, and we're going to graph it. Okay, so we know the answer is roughly, looks like 1, 1, maybe 1, 0, something like that in there. So we had, let me check and make sure I got them right, negative x plus 1, and 3x minus 4. So we're going back to the graph. We want to find the intersect. So second calc, 5. And I'm going to hit enter 3 times. Look at that. The intersect is 1.25, negative 0.25. Now you can imagine if we would have tried to solve this algebraically or, any other way, we'd have had a couple issues going on. So that's important to understand how quickly this thing gets us to the right answer. That would have been difficult to figure out, algebraically with the fractions or whatever. So definitely helped us out. Now, if you had a question about how these fractions work out, we can hit put 1.25 in, hit math enter, and you get 5/4. And then we can put 0.25 in, hit math enter, and we get -1/4. So if you had to be able to put it in that way, you could do it that way just by checking your graphs. So this covers equations. We're going to pick up with inequalities in the second video. So go ahead and switch notes and go to the inequalities.